Let's talk about the language we use when we're describing how the derivative function relates to the original function. A lot of times we say things out loud and we don't have the time to process each little individual word, but each little individual word can make a big difference in how we're understanding things or misunderstanding things. So it's good to have stuff written down, so that's what I'm trying to do in this video. So here I have a nice function and its derivative. I've heard some people say that the derivative mirrors or looks like the original function, but would you say that's true here? I think these two functions are quite different. One of them goes negative, the other one doesn't. One of them increases and then decreases, and that's it. The other one increases and then decreases and then increases again. So I would not say it's always true that the derivative mirrors or looks like the original function. In fact, it's hardly ever true that the derivative looks like the original function. And some people say mirrors, and I'm not sure if they mean like an exact copy or a flipped copy, because mirrors flip things. But either way, it's still not something I would say. Some people have the idea that when the derivative is positive, the original function is positive. Is there a point on this graph somewhere where you can point to something that contradicts the idea of where the derivative is positive, the original function is positive? The original function is always positive here, but the derivative is sometimes negative. So apparently we can't trust the sign of the derivative to tell us about the sign of the original function. Now let's get into something more subtle. Some people say when the slope of the tangent line is increasing, the derivative is positive. Let's move our point of interest back over here. So we have to be very careful about what we say about the slope of the tangent line being positive versus the slope of the tangent line increasing. If the tangent line is increasing, then its slope is positive. That's true. But if we say the slope of the tangent line is increasing, that means from one tangent line to a nearby tangent line, the slope got bigger. And we'll talk about that in the next video. But we don't want to say the slope of the tangent line is increasing for any one particular tangent line. To say increasing, you have to talk about two adjacent or two nearby tangent lines, or more than two. So if someone says where the slope of the tangent line is increasing, the derivative is positive, that's actually getting more at something called concave up, concave down. But we don't want to say this if we're just looking at a single tangent line. Maybe the tangent line is increasing, maybe its slope is positive, but we don't want to say the slope of the tangent line is increasing. And from that conclude that the derivative is positive. If we said when the slope of the tangent line is positive, the derivative is increasing, does that sound reasonable? Well, here the slope of the tangent line is positive and the derivative function is increasing. It's also positive. But over here, the slope of the tangent line is positive. The tangent line is increasing and the original function is increasing, but the derivative, as I move this line that way, the derivative itself decreased. So when the slope of the tangent line is positive, the derivative is positive, but not necessarily increasing. So what we do want to say is that when the slope of the tangent line is positive, rather than the slope of the tangent line is increasing, or we could say when the function itself is increasing, the derivative is positive. Let's check that here. Here, the slope of the tangent line is positive, and the y value of the derivative is positive. And that's true all the way up here, and even right there. Well, yeah, the slope of the tangent line is positive, and the derivative value, the y value, is positive. And then once we get over here, the slope of the tangent line is negative, and the y value of the derivative is negative. But here, remember, we would not say that the slope of the tangent line is decreasing right here. We would have to think about here versus somewhere else, and that's about concavity, and we'll get into that later. So remember, on this diagram, we're only talking about one tangent line at a time and not talking about what happens to the tangent line if I move from here to there. That'll be in our next video. All right, so It might be worth writing down each of these statements that is a good thing to say or not such a good thing to say, and maybe circling what element of the statement was misleading us. So like in this one, when the slope of the tangent line is increasing, the word increasing is the trouble there. We need to replace it with the word positive. All right.